Okay, so today we're going to talk about partial fraction decomposition. It's used for integrating rational functions. Rational functions are fractions where you have polynomial divided by polynomial. So I'm calling these P and Q. And the point of this first video is that it's only going to work if the degree of the top, that's the degree of P, is strictly smaller than the degree of the bottom. Otherwise, we're going to need to use long division first. So now I'm going to give you an example, namely this one, where my P is x squared plus 2x and my Q is x plus 1, and the degree of the top is actually larger than the degree of the bottom. So I need to use long division first. So let me show you how to go through the long division procedure and see how that actually helps us integrate the rational function. So we set up the same type of notation that you learned for numbers. This means x squared plus 2x divided by x plus 1. And now we're going to figure out what we need to multiply x plus 1 by, the largest thing, so that when we subtract from here, the x squared actually cancels out. So what do I mean by that? The trick is the following. Take the leading term here, x squared, the leading term here, x, divide them, x squared divided by x is x, and that's what we're going to multiply by up top. So I want to take this times that, put it underneath and subtract, just like we do for numbers. So x times the quantity x plus 1 is x squared plus x. I'm going to subtract that from the top. I'm putting parentheses around this because both of these are going to be subtracted. And the point is, by using this choice of x, when I subtract, these x squareds are going to completely cancel out. What do I end up with? I end up with 0. 2x minus x is x. And now this is not degree 2 anymore, it's degree 1. We repeat the procedure. X divided by x plus 1 now. Well, the leading term on the bottom is x, leading term here is x over x is 1. So I want to multiply by 1 next. 1 times x plus 1 is x plus 1. Subtract. Now these x's cancel, and I just end up with negative 1. This is my remainder. We'll know we're done when what we get here has a lower degree than what we were dividing by. This constant, negative 1, is degree 0. The polynomial we're dividing by, x plus 1, is degree 1. This has smaller degree. So our conclusion now is that x squared plus 2x divided by x plus 1 is quotient, x plus 1, plus remainder over what we're dividing by, just like we did for numbers. Now, if this is something we can integrate, we're good to go. And in fact, it is. So now I can actually finish the original problem. By the way, this is a polynomial, and this is a rational function where the degree of the top is smaller than the degree of the bottom. So coming back to the original question, this becomes the integral of x plus 1 minus 1 over x plus 1 times dx, which equals, okay, polynomial, 1/2 x squared plus x minus, now here technically we are doing a u substitution and letting u equal x plus 1. Since its derivative is 1, writing out the whole u substitution is really unnecessary. I'm going to get minus the natural log of u, where u is x plus 1. So this is the log of absolute value of x plus 1, and then plus c, and we're done with the problem.